Yeah, hello. I'm Victor Kropp from Jetbrains, and this is going beyond JVM with Kotlin. So we are at Java Day, and I suppose all of you are Java developers, right? So what kind of stuff do you do? Do you work on web services, some web applications? I don't know, using Spring. Anyone from the web backend side? So I see some people. Okay, you have a web backend. Do you have a front-end part in your application? So some HTML, JavaScript, CSS, so on? No, yeah, that's obvious. Of course, you cannot have just the backend. But modern applications also have mobile variants. So like Android developers here. Maybe by any chance iOS developers? Well, there are some. Cool. Well, the world is not limited to mobile phones. We also have desktops, our powerful desktops and laptops. And often we have special versions of our applications for desktops. Do you do some desktop development? Anyone? Wow. This is surprising, because we mostly do desktop development with our IDEs. Anyway, so there are a lot of languages used in modern development. So you can do your server side in Java, that's obvious, but Python and Ruby, especially Ruby on Rails, is very popular on the backend side. And you have front-end in JavaScript, and a lot of languages that compile to JavaScript. Maybe one of the most popular ones is TypeScript. And you develop Android applications in Java or Kotlin. And on iOS, you use Objective-C or Swift. And there are a lot of languages used on desktop, from C, C++ to C#, for example, for modern Windows applications, and Swift and Objective-C on Mac. And there are a lot of languages. And the problem is not only that these languages are different, and they also have different paradigms. Some of them are interpreted, some of them are compiled. Some of them have dynamic typing, some have strict typing, and so on. And some have garbage collector, some do not have. And it is really hard to develop a full-stack application nowadays, because you need to a lot of languages, a lot of technologies, a lot of build systems around these languages and technologies. And what if we can just go away from all these zoo of languages and just use one language for everything? And this language is Kotlin, of course. So I would like that the picture will look like this in a few years. So you do Kotlin on server side, you do Kotlin on Android, iOS, you develop web applications in Kotlin and desktop applications too. Well, to be correct, it should look like this. So there is a language in Kotlin, and it has a number of compile targets. So it has all started with the JVM, with the Kotlin JVM. So back in 2010 or 2011, some group inside of JetBrains decided that we have a huge expertise in Java, and we see the shortcomings of the language, we see where can we do better, and decided to develop their language. And the initial goal was like to build a better Java, the language for JVM that will be more fun to use, more fun to program in it, and to avoid some common pitfalls in Java. But quite soon, we realized that we can compile Kotlin into JavaScript, for example, using some different compilation target. and to bring all the language goodies to JavaScript, to web applications, to avoid. So when you develop in JavaScript, you usually only know that something went wrong when you run your application. With the statically compiled language with the strict typing, you can avoid a lot of problems on compilation time. And last year, we also announced a Kotlin native project. The aim of this project is to bring Kotlin to native development, so it is a compiler that compiles Kotlin into native code without any virtual machine inside. So it uses LLVM and produces machine code for selected architecture. And this is how we want to bring Kotlin to iOS and desktop applications and also to maybe embedded devices. So Kotlin JS target was announced in Kotlin 1.1. It is already available, and Kotlin native is now in the preview phase, so you can play with it, but it's not yet ready for production. So who has already tried Kotlin? Okay. Do you use it in production? On Android? Web? On backend. Cool, cool. So for those who do not know what Kotlin is, so the summary on the web page is it is a statically typed programming language for modern multi-platform applications. And my goal today is to talk about multi-platform applications, so I will not dive deep into language features and syntax. So the main advantages of Kotlin is that it is statically typed, for example, compared to JavaScript. It has very concise but expressive syntax. It emits a lot of unnecessary ceremony around your code. So no more semicolons, a lot of we got rid from a lot of keywords and so on, but it's still very readable, and it's very important for big projects, big applications, because we spend a lot of time when we doing development. We spend a lot of time reading and navigating, analyzing code. Actually, from some researchers, as far as I remember, it's like 80 to 20. We spend 80% of our time reading code and only 20% time developing code. And we'll get it a little bit later. And also one of the goals of Kotlin from the very beginning, and I think it was one of the pillars of success of Kotlin, is that it is 100% interoperable. It is, for example, in JVM, it is 100% interoperable with Java, and actually in both ways. You can extend Java from Kotlin, you can extend Kotlin classes from Java, you can use Java from Kotlin and vice versa. So it's all transparent, and actually in simple cases, the bytecode generated by Kotlin compiler is exactly the same bytecode you get from the similar Java classes. So it introduces only a little overhead. And the same applies, for example, to JavaScript, Kotlin JS target. We do not want to build a whole new ecosystem around Kotlin. We want to integrate Kotlin into existing JavaScript ecosystem. I will show an example how you can create, for example, React application in Kotlin. So with just a little bit of wrappers around native React APIs, which are easily updated for new version. So you don't need to recreate, for example, React framework, which is huge to write React-like applications in Kotlin. You just use the real React framework. And just quick overview for small language features. Kotlin also is by default null safe, so all types all variables, all fields you declare in Kotlin are by default non-nullable, and only if you want to use nullable fields, you put a question mark after the type name. So this is how you can can use nulls, but it's really not encouraged by the language. By default, it is non-nullable. And saving a lot of typings for you, for example, Kotlin, instead of having a private backing field and getter and setter methods in Kotlin, you just declare a property. And also there are very powerful extension functions in Kotlin which extend existing classes. For example, you get from JVM, you can extend them with your own methods and call them like if they were instance member methods of those classes, even if these classes are third-party or standard library and so on. This is again about interoperability with the existing code, and we'll see some examples later. So that's all about the language. I don't want to spend much time on it. If you want to learn more about Kotlin, I encourage you to go to try.kotlin. It's a small, it's online IDE, kind of, with a lot of small tasks and examples of Kotlin code, and each example is accompanied with a test or a number of tests. So you implement a simple function, and it is verified instantly in the browser if you did it correctly. It's a great way to learn the language, even without reading the documentation, which is of course available on the website kotlinlang.org. And also there is a book by my colleagues, Dmitry Zhemerov and Svetlana Isakova, Kotlin in Action, so about language from the first hands. So let's focus on the multi-platform, cross-platform development. Why is it important? I've said before that I want to write all the parts of the application in the same language. This has a lot of advantages because everyone on your team speaks the same language. Eases collaboration, eases onboarding of new members on your team, and reduces so-called buzz factors. So there are fewer key people that know how the things work. You can easily replace missing members of the team if you need to. And also, you don't split your team into different smaller sub-teams working on different applications. So, for example, mobile applications for iOS and Android are quite different. And if you use the same language, you can develop both applications in the same project. For example, in the IntelliJ IDEA, you can develop both at the same time. And this, of course, simplifies the full stack development, as I said. You may be, for example, if you're a backend developer, you may not know how this weird positioning works in old Internet Explorer, for example. There are a lot of different quirks in web development, but still, if you develop some new feature, you can quickly prototype a UI for this feature, even if you don't know HTML, CSS, and so on. So the biggest advantage of sharing code between platforms is, of course, sharing data structures. So your parts of your applications talk to each other via some API. This API provides some data. Even in simplest cases, your data structures grow quickly. And if you use different languages, different projects for each part of your application, you need to update all of them one by one on each change. And for example, you can easily mistype some field in your data structure and everything breaks, and you spend a lot of time debugging it. If you use a single source of truth, you are safe. Every change applied to all platforms immediately. Yeah, there are solutions to this. For example, defining audio structures in protobuf, like this one of the widely used solutions. But still, it implies that you need an additional step generating real data structures for each language and platform you use. Sharing code also enables you to share business logic. There is a lot of common logic between different parts of the applications. Like, I don't know, you need to validate user input on web. You always need to validate it. So you build your validation logic into your web server. But connection is slow, the round trip is can be big, so you also need to build the same validation into your web application. And if this code differs, you can get into trouble because for example, you validated all user input on the web part, user thinks that everything is okay, it submits she submits a form, and then there got error. Not very good experience. When you share this logic between different parts, you are safe. You always validate the same things on all platforms. And this also means you can share tests for your business logic. So you are always sure and confident that your code works as it is intended to work. And you implement it once, and you test it once, and it works in the same way on all platforms. But the thing is that I personally, and well, the overall, so this is good recommendation not to share UI between the platforms, because each platform has its own look and feel, and not only in how the different UI elements are presented, but also in the behavior. So we don't have a goal to implement any UI framework in Kotlin, because when we try to target all the platforms Kotlin supports, we will be limited to a very small set of controls presented everywhere, like text input and button. I don't know. And each platform has its own UI controls, own behaviors, own transitions between controls, own ways how to present, I don't know, dialogue, windows, and so on. So the thing is, you better write all your business logic and share it between platforms, and then implement the UI in different platforms using their standards, their guidelines, and so on. But you can do it in Kotlin anyway. So how multi-platform projects in Kotlin work? So you have well, you essentially split your application into different modules. You have a common module, which contains only pure Kotlin code without any platform-specific dependencies. So this is only Kotlin code, and then you have platform-specific modules, for example, Kotlin JVM, Kotlin JS. These modules can contain platform-specific code like Java files or JavaScript. And then, when you compile, a common module is compiled to some kind of metadata. It cannot be used directly, but it used in platform-specific modules. And together with them, it compiles to actually executable code on the specific target platform. So one of the ways to use to share code between platforms in this way is to declare some interfaces in common code and then implement them on platform-specific targets. But this is not the approach we've taken in Kotlin. Kotlin approach is different, and it is a set of expect and actual declarations. So you can think of them like I don't know, header and CPP files in C++, so where you declare some interface, some classes, some methods in common code, and you put expect keyword on a class. So it's a normal class, but without any implementation. So like abstract class, but not really. And then on each target platform, you declare an actual class where you implement everything declared in expected class. So for example, we have here a constructor. So this is after a class name, you can put a number of parameters in Kotlin, and this will be a primary default constructor in Kotlin. So we need to declare an actual constructor in platform-specific code, and then declare an actual function, member function of this class in the platform-specific code. And here we already see an advantage of this approach over the approach with interfaces. So if you share your code and have a platform-specific code shared via interfaces, you cannot declare a constructor, for example, in interface. But with this approach, you can. And also, these expect actual classes do not give you any overhead. So in real, for example, in JVM and bytecode, it will be compiled to a simple class without any interfaces that it extends. It will be just plain class. And another non-obvious advantage is that if you have a common module and, for example, two platform modules, JVM, JS, you declare expect class in a common module, you implement this class in JVM, for example, and compile will give you an error if you do not implement this class in JavaScript platform. So compile ensures that all your expected classes from common module implemented in all platforms you are using. This again may be a surprise on the runtime if you using interface approach. Another thing that can be achieved with this approach is that you can declare some expected class in common module. In this case, in this example, it's an annotation class, test. And then you can use type alias feature of Kotlin to provide an actual implementation that already exists. You do not need to re-implement everything. You delegate this expected class to existing one. So if you are using test annotation in your common code, in JVM it will be translated to JUnit test, for example. And also this is useful, for example, if you like some existing class present, for example, in JVM, we have big decimal, and there is no such thing by default in JavaScript. So you declare expected class with all the methods you need. You don't need to repeat all of them. So this will compile. So you delegate this common big decimal class to Java Math big decimal, and you are ready to go. You only need to re-implement these all required methods from big decimal in JavaScript platform-specific module. And then you will be able to use these on both platforms transparently. So, enough talking. Let's get to some. Let's see some code. So, I will scale it a little bit to show you more. Do you see it good? Oh, okay. So, this is a build Gradle file. Okay. So, what we will have here is 5 modules, because we are writing big enterprise to-do list application. We'll have a common module shared between 2 platforms, JavaScript and JVM. It is also an Android platform is already supported, so you can write code, Android-specific code in a separate module. This might be useful because Java Kotlin on Android is not the same Java that we have on JVM on desktop, for example. And we will have server, which is backend written in Kotlin JVM. This is a normal module. And web, which is a Kotlin JavaScript module to write UI. So, and this is build Gradle file of the common module. And here we see that instead of applying Kotlin plugin, we apply Kotlin platform common plugin. And in dependencies, we only use those that have common. Yeah. So here, you see, we have the dependency should have a common suffix. So, well, this is a special artifact. Which is a common, only common code, which is pure Kotlin. This is the only you can use from platform, from common module. So, and here, what we will have here is so. I hope you can see it. So we have a class for storing our to-dos. They will have an ID, a text, and a date time when they were added. And we will put them into high-level structure of to-do list. So this is not, we don't see any expect actual keywords here, because this is the code which is already complete, and we can share it as is between the platforms. So you don't need to re-implement everything on each specific target platform. You just have it implemented in common model and reuse between the platforms. But the DateTime class here, it is marked as expect with expect keyword, because we have different DateTime APIs on different platforms. So it will be very simple. Just constructor with the long and a method to format the data to present it. Let's see how it is implemented. So here we are on the Java side, and I quickly implemented it using Java DateTime APIs with the instant and date formatter. And we have and in JavaScript module here, no. What's this? Okay. Okay, yeah, here we are on the JavaScript side, and on JavaScript side we use moment library to deal with the dates and times. And here we can navigate to moment. This is a simple declaration that is marked with keyword external and defined externally. So that this is how we can use existing JavaScript code from our Kotlin code. So we in npm we add the dependency for moment library, and then in Kotlin we just delegate these Kotlin methods to native JavaScript code. There's a kind of similar things to definitely type in TypeScript. So and how do we use it? So here's a server written using Ktor framework in plain Kotlin. So I will collapse this for clarity. So we just define. Let's make it bigger. So we define the number of APIs. This is HTTP REST-like API with the get, post, put, and delete methods for our to-do items. And for example, let's take a look here. We use the Kotlin serialization library to serialize and deserialize these to-do items from JSON. And it is using the to-do items we declared in common code. So let's see how it works. So here's our to-do application on the Kotlin side, on the website, we use React with the Kotlin React wrappers, as I told earlier. So these are pure Kotlin APIs to create React components from the from Kotlin code. These are using extension functions and Lambda and a special notation for invoking functions with the Lambda parameters. So this we have a to-do item here and an input field with the button to add new item, and to-do item is well, where is it declared? So here it is. It's just print a paragraph with some text. So, and yeah, for example, let's restart the server in debug and see how it. What's wrong with it? Okay. So I need to restart. Something went wrong. Sorry. So I will restart and show it right now. So anyway, the source code of this example I put it on GitHub, and you can try it yourself. Check how this sharing between the platform is working, and you can play with this code, add something to common code, and see how it easily can be reused from the both target platforms. While I'm starting this now, maybe we can proceed to questions. Are there any questions? I will restart everything now, and we'll show it.
Show the questions on the screen?
Yeah, you can. So, the questions. Do you have any plan of production release for Kotlin native? Yes, we do have. We plan to release Kotlin native, but we never give any estimation. We are releasing our products as soon as they are ready, and they are ready when they are ready. Sorry, that's all I can say. So, okay, as far as I know, LLVM needs simple integration layer of compiler frontend. Is it dist? Okay, let's get back to it later. In cross-platform development, can we share any view between Android and iOS? So as I said, I personally don't like when the UI is shared between different platforms like Android and iOS. They are quite different. So my personal suggestion is to implement UIs different on different platforms and just reuse business logic. But with Kotlin, you can do something like UI reuse for commonly used components. Like you can define some your custom kind of DSL, domain-specific language for UI descriptions in the common module, with the specific parts re-implemented in different platform-specific modules, and then reuse this DSL to build some common UIs universally. But really, all platforms have their own behaviors, so I don't think that this is a good approach. This is my personal opinion. I don't like it. Yeah. Yeah.
How can I sell the idea of using Kotlin for manual interoperability or
Nice question. Well, actually, there is a project. It is called Corda, It is, well, if I make any mistakes in description, you may correct me later if you know it better, but it's kind of blockchain to exchange information between different banks, and it is thought as a replacement of SWIFT system, which is used widely to transfer money between banks. And this Corda project is written entirely in Kotlin and is already, as far, I'm not sure, but I think it is already used by some banks. So there are banks that are already using Kotlin in real world in production. So maybe this is this could be a good thing to tell your manager. And also, well, JetBrains is quite old and established company already. Kotlin is open source, so it's not going away anytime soon. Kotlin is officially supported by Google on Android. I don't see any reason not to do Kotlin, actually. Okay. So I have answered. Most Android developers face the method count increase issue on the DEX. Well, Kotlin standard library is quite small. It doesn't increase your method count significantly. You can use ProGuard to skip some unused methods. You can use multi-DEX to split your application in several DEX files and avoid delimitation in this way. And anyway, many developers think that the advantages Kotlin gives you for your application development are much. There are more advantages than disadvantages just in method count. This would be my answer for this. Yeah, let's get back again quickly, and I will show you. So I restarted the server in the debug mode, and we can go to our API, and for example, to post API to the method called on new to-do item. So let's add new item. We have switched to IntelliJ to seed, and so the request body here is, oh, it's very small. So we have a request body down here. So I can probably show it like this. In the middle of the screen. So we have text and DateTime serialized, and this is our to-do item we declared in common code. It is transparently serialized on JavaScript into JSON, and then we can parse it, and here we got a to-do item on JVM with the same data. So it just works like charm everywhere. So that's it. I would like to encourage you to try it by yourself. Just get the code. It is ready to use. You can just run it in IntelliJ and try it yourself. So if you have any questions, so thank you for attention. If you have any questions, so the time is over, and I answered some questions. But if you have any additional questions, I'm at JetBrains booth over there. Or come to chat with us about Kotlin, about our tools. We also have some discounts there. So see you and enjoy the conference. Thank you.
Thank you for good presentation.
Thank you.